Hi, and welcome to Unit 7, Day 4. This is the example problems from the worksheet. So in getting started, before we get started, I just want to go over the process with you. We are solving mass-to-mass reaction stoichiometry problems. So we're given the mass of one substance in the reaction, and we're trying to find the mass of something else. And the first thing we need to make sure is that our equation is balanced, and if it's not balanced, to balance it. Once we've done that, then we are going to go through the process of taking the mass of our given and converting it to moles of our given using the molar mass. To get the molar mass, you use your periodic table. Then after we have our moles of given, we're going to take our moles of given and convert it to the moles of fine using the coefficients in the balanced chemical equation as our mole ratio. And so remember, the coefficients are the big numbers in front of the substances in a chemical equation. You need to, of course, balance it first to get those coefficients. Once we've got our moles of fine, then we're going to convert from moles of fine to the mass of fine, again using the molar mass of what we're looking for, and again you use the periodic table for that. So in this first example problem, I'm actually going to walk you through and speak about, as I solve the problem. And then for the rest of them, I'm actually going to solve them silently. And the purpose of doing that is for you all to start using your thought processes. When you see me doing something, think about why I'm doing it and predicting the next steps. If I'm talking, I actually prevent you from learning more actively. By solving it silently, it forces you to learn more actively. Okay. So let's begin. In this first example problem, it says 14.6 grams of sodium metal reacts with excess chlorine gas to form how many grams of solid sodium chloride? So the first thing I want to do before I tackle the problem is make sure that this equation is balanced. So to make sure the equation is balanced, I'm going to do a tally of the atoms on both sides. So I have sodium, and I have chlorine, and I notice I have one sodium atom because there's no subscript next to the sodium, a numerical subscript. That S, by the way, is just because it's a solid. This G is because it's a gas, and that S is because it's a solid. So these are just phases that are next to it. So I have one sodium atom, and then number of chlorine atoms, there's a subscript of 2 next to it, so that means I have 2 chlorine atoms. On the product side, I'm going to have the same number of atoms. Remember, the products are going to be to the right of the arrow. And in this case, I have just one sodium and one chlorine. All right, now what I want to do is check to see if it's balanced. So I have one sodium on both sides. Okay, they're good, but the chlorines are not because I have 2 on the reactant side and 1 on the product side. So I need to double the number of chlorines that are on the product side. And to do that, I'm going to change the coefficient number in front of the molecule that chlorine's in. So I'm going to put a 2 in front of the sodium chloride. That gives me 2 chlorine atoms. And it also changes the number of sodium atoms. Remember, when you change the coefficient of the molecule, the number of all the atoms in that molecule must change as well. All right, so now I'm looking at my chlorines. They're looking good, but my sodiums are no longer balanced. So now I need to figure out how to balance those. So I have 1 on the reactant side and 1 on the product side. To balance that, I'm going to change the coefficient in front of sodium metal, and now it's balanced. Okay, so that's first step before you start this problem, is to check and balance. Now we're going to go into this step-by-step process of converting to go from our mass of our given to our mass of our fine. So what I'm going to do here is I'm going to write above the substance. I'm given 14.6 grams of sodium metal. So above sodium, I'm going to write 14.6 grams, just so I'm keeping track. And reacts with excess chlorine gas to form how many grams of solid sodium chloride. So I'm actually looking for the sodium chloride because it says how many grams of solid sodium chloride. Now, by the way, this excess chlorine gas, the reason why that language is in there is because when you're doing a reaction that has more than one reactant, you need to have the right amount of each one for the reaction to go. And just like if when you're cooking, sometimes you'll have more of one ingredient than the other. And the one that you have more of is sort of your excess ingredient, right? So the same thing is true here. This would be our excess ingredient. And the one that you have just enough of, that's going to determine how much food that you can actually make. So in this case, the amount of product that we can make will be determined by the thing that's not in excess, what's called our limiting, which you'll see later. So they include this language here to say that you have more than enough chlorine to react with all of the sodium metal, so you don't have to worry about the chlorine impacting how much product you can make. It's just going to be based on the sodium metal. Okay, so now that we've gotten that, we've balanced our equation, identified our given and our find, let's go ahead and start solving now. So the first thing I want to do is convert from mass of Na to moles of Na. And to do that, I need to use the molar mass of sodium. So I go on the periodic table. The molar mass of sodium is 22.99 grams. So that means 1 mole of sodium is equal to 22.99 grams. Okay, so solving this using dimensional analysis, I'm going to take my given 14.6 grams of sodium, and I'm going to put it over 1 just to make it into a fraction. Then the second fraction is going to come from my conversion factor. So I'm going to just take this information and turn it into a fraction. So for this part, I'm going to put the 22.99 grams on the bottom because I want grams to cancel out, right? So the part of the conversion factor that goes in the bottom will depend on what you want to cancel out. Since I want my grams to cancel out, I need to put the part that has grams in the denominator. And then the 1 mole goes on top. Okay, so now that that is done, I can go ahead and do my math here. The work here looks like this. I'll write it out, it's easier to see. 14.6 divided by 22.99. That's what I'm doing. And that gives me the moles of sodium, 0.635. And I'm using 3 sig figs because that's how many significant figures I start off with. 1, 2, 3. So I get 0.635 moles of Na. Okay, the next step is to convert from moles of Na to moles of my fine, which is sodium chloride. Okay, so for that step, what I'm going to do is I'm going to take the moles that I got of Na from the previous step, and that's going to be what I'm starting with here, 0.635 mole Na, and I put it over 1 just to make it into a fraction. Now for my conversion factor here, I need to use the coefficients in the balanced chemical equation. So this is why we had to balance our equation. We go back to our equation. I'm trying to convert from moles of Na to moles of NaCl. So I have to find those two things in the equation. I see there's 2 moles of Na, because there's a coefficient of 2, so 2 moles of Na is equivalent to 2 moles of NaCl. Now, you can simplify this because this is essentially a 2 to 2 mole ratio. That's the same thing as saying a 1 to 1 mole ratio. So 1 mole of Na is equal to 1 mole of NaCl. You can use either numbers if you want in your balanced chemical and as your conversion factor. It's going to do the same. I'll give you the same value. Okay, so I'm going to use this one, the simplified one. So I want to get rid of or cancel out moles of Na. That means in the conversion factor, moles of Na has to go on the bottom. So I'm going to put 1 mole of Na on the bottom. So that part goes on the bottom so that the units can cancel out. And then on the top, I'm going to put the 1 mole of NaCl, which is what I'm trying to find. Okay, so now that I've done that, it's a simple just 0.635 times 1. So this will give me 0.635 moles of NaCl. And that should sort of make sense to you. If it's a 1-to-1 mole ratio, that means if you have 1 mole of Na, you can make 1 mole of NaCl. Therefore, if you have 0.635 moles of Na, you can make 0.635 moles of NaCl. This is the sort of math that you probably could do mentally. You don't even need to, if you were doing this quickly, you wouldn't even necessarily need to write out this step, but I am showing you the work for it. Okay, the last step that we need to do is to go from, I'll write it up here, our moles of NaCl to the mass of NaCl. And to do that last step, we again need to use the molar mass. So I have to go to my periodic table. So look at 1 mole NaCl is equal to what? All right, so to calculate the molar mass of NaCl, since this is not a single atom, I need to calculate that. NaCl is made up of sodium and chlorine. So 1 sodium, 1 chlorine. So I need to add up there to 22.99 plus 35.45. And that's how I get the molar mass of that. So 58.44 grams. Okay. Okay, so now that I have the molar mass, now I'm going to go ahead and take my moles of NaCl that I got in the previous step, and that's what I'm starting off with here, 0.635 mole NaCl over 1. And then here, this conversion factor, again, will come from the molar mass. In this case, I want to cancel out moles of NaCl, so that means that the 1 mole of NaCl will go in the denominator. They need to be opposite, right, to cancel out. And then the mass, 58.44 grams, goes on top. So the math here will look like 0.635 times 58.4. And that gives me 37.1 grams of NaCl as my final answer. Okay? So this is pretty much the process you'll be using for all these problems. Now in the next video that you'll see, I'll be solving the other example problems. If you think you can get it without seeing me solve them, just go ahead and do it. If you want to see me solve them, that's fine. I will not be talking during those videos, so just so you know, it's just for you to see what it looks like to solve. And before I go, I just want to show you about the units canceling out. So in all these conversion factors, we're using them to cancel out units we don't want. So you can see here in this first one, we're converting from mass of Na to moles of Na. To cancel out, the grams of Na cancel out because they're opposite. In this one, we're converting from moles of Na to moles of NaCl. The moles of Na cancel out because they're opposite. And then finally, for this last one, going from moles of NaCl to grams of NaCl, the moles of NaCl will cancel out because, again, they're opposite. All right, I hope you found this video helpful. Have a quality day.